Oh, excellent. Because... Okay. Alright, so you should be able to hear now, right? Okay, I hope that YouTube didn't set the setting to, let's see, did it set it to, oh, I hope it didn't do that. It always sets it to, like, uber long latency period, which really is unfortunate, because then your questions are, like, 20 seconds delayed, which makes it look like I'm not really paying attention, but... Yeah, I actually tried to mute it because I was about to sneeze, but I couldn't mute it in time. But it's great because it was already muted, so I guess I didn't have to do anything. Okay, now that I've wasted 5 minutes of class times, why were the lectures unlisted? Apparently, for a while now, university lawyers have been thinking, like, do we want the public to have access to these lectures? Or, I think technically, basically, the idea is that they're the property of UMBC, and so they're like, well, we don't want anyone watching them, so they just want only people with the link to watch them. It's reasonable, I suppose, but I do think it's probably going to hurt attendance pretty significantly, which it already has, I think. So it's not good, but I can't really, I mean, I'll try to do my best to overcome that. I think what I've done, I've just created a command in the bot. Let's see if the bot will do, let's see if it'll do it in real time. I just wrote code. It is completely untested. Okay, so I got a DM from the bot. Oh, it sent me a link. There we go. It works. At least for today. At least right now. Can you make a pin of all the previous lectures? Yes. I can do that. I'm gonna post them on Blackboard. I'm gonna post them on Discord. Basically, like, now that they're unlisted, I'm going to have to be way more communicative. You can, if you have the link, which is why I'm going to collect the links and post them. Okay. Maybe I'll make it, or just lecture. Something like that. I mean, we can adjust that. Anyway, let's begin our lecture for the day. So today we're going to be talking about for loops and lists. And the reason why, and if you guys want the actual slides, here's a link to the slides. So the reason why, I think normally they used to divide this into 2 separate lectures, but I realized that there's really no reason to do that. Like, lists in Python and for loops in Python are basically like dual structures, if you know what I mean. They're things that work together. So if you have a for loop without lists, you're not doing a whole lot, and if you have a list without a for loop, there's not a whole lot you're doing either. So we're going to kind of introduce them over the set of 3 days and just kind of do as much as we can per day to, go through our understanding of lists and our understanding of for loops. And so you might think to yourself, like, wow, that seems like 2 separate topics, but you'll see that really they're the same topic when we, when we get through with all of this. And it'll be hopefully a gentle introduction. So what is a list? A list is an object where Python has multiple slots or indices. So what do I mean by that? What I mean by that, and let me see if I can flip back and forth between the code. So a list is basically something where, let's say that you want to store more than one thing in a variable name, right? So we want to store 2 things in a variable name. Or 5 things. 10 things. Whatever. So the thing is that if you just store a list equals 3 and then you say like a list equals 4, then you see that this is not going to work, right? Because this is just going to reassign the variable a list, and remember, Python doesn't care that we're calling this a list. It's just an int right now. But if we declare a list equals, and then you have to use the square brackets separated by commas. Say we do this, and we print it. There we go. So now, what the heck is the thing that we've just done, right? This is not a string, and yet Python seemed to know how to deal with it. So basically, this is a variable. It's a single variable, but it contains multiple entries. So basically, the idea here is that each variable name for a list can have multiple entries. Okay, cool. So what does that mean in a practical sense? So we use the square braces. I should have modified that years ago. Maybe I'll modify that right now. Okay. There we go. So basically, my list equals 1, 2, 3, 4, 5. That is the declaration of a list. My string list equals hello, goodbye, robot. So as it turns out, you can put basically anything inside of a list. So you can make a test list equals hello, 3.2, true, false, none, whatever. So basically, you notice that Python isn't very strict about lists being all the same type. So you can print out this test list, for instance, and it's going to print out just fine. There's no problem here. That's good and bad, right? Because if you make a list of all different types of elements, you have to remember that you can't just operate on this list as usual. You have to remember that it's possible that, like, for instance, you can add strings, but you can't really add the none object, and if you add strings, it'll concatenate. If you add numbers, it'll add. So you can't really trust the plus sign in elements of this list, right? If I just give you A and B out of this list and I say add them, you might say, wait, I don't know if it's going to be the same type, right? So, and it's a completely valid criticism. You don't know if it's the same type. So generally, you want lists to be of the same type. And now, it could be that they're of type list, or dictionary, or string, or int, or whatever. But as long as they're of the same type, then you know that you can perform operations on each element, right? Without knowing too much about each element. You're like, I know all the elements in this list are integers, so I can operate on those elements without having to be, like, too concerned about the individual, types of each thing. I'm just, I don't know why I'm spending so long on that. Let's keep moving. So here's some more examples of lists. So lists can be of mixed type, as I said. Here is an example of a mixed list. And, I mean, there's nothing wrong with this Pythonically. Like, you can do this, right? It's just that if you ever want your list to be something that's kind of useful for, like, operating on, it's hard to be safe when you're operating on strings and nuns and ints and floats all at the same time. And incidentally, I mean, Futurama is definitely like one of my go-to references. I think I probably reference Futurama and Star Trek Next Gen more than like any other cultural reference. So if you haven't seen any of those things, I suggest you watch them. But not right now. So here's another list. So here's a list that has some numbers in it. I picked those numbers because they are the computer scientist's favorite numbers, right? And so it made of powers of 2 for some reason. So here's a crazy one. Here's a list which has some sublists in it. If you're having trouble with homework 2, office hours, right? Office hours. Or send me an email. I can't really do a lot during lecture. So list of lists. So here we have 3, and here we have a sublist, right? It's a list inside of a list containing the elements 1, 2. Here we have 17. Here we have the string yep, and then here we have, yeah, this is like a 1.5 dimensional list because here these are singleton elements, but then these are sublists. So you might call this a 2D list. You might call this a strange list with just some kind of weird, I don't know what. So like, it's different. But I'm just kind of, the reason why I'm showing you all this is not because I think that all of these lists are good ideas. I'm just showing you kind of like the limits of what Python is capable of. And then you can make a decision whenever you're implementing your own homeworks or projects. You have to make the implementation decision of what you're actually going to do with lists. Who in their right minds would ever do that? Yes, it's okay, cool. Yes, I say all kinds of stuff in my lectures and then I just don't read it. Okay. So, I don't know, you guys have to tell me if you like the slides or don't like the slides or whatever. Maybe you find them that they keep me on track. Apparently, one of my TAs yelled at me for being a little bit distractible during lectures, which I suppose is fine. What's my opinion on Star Trek Picard? It's too complicated to get into right here. Maybe we'll talk about it on Discord. So sometimes you need an empty list. And so what is an empty list? An empty list is a list with no elements. So basically, it's like in set theory, which, of course, you might not have seen before, but if you've ever heard of the empty set, which is kind of like that var nothing symbol. Let's see, what's the quickest way to get to empty set? I don't know, who cares? That's not here. So why you ask? Because you can add things to it later. So lists are a variable type that's called mutable, and we'll talk more about mutability later, but basically mutable just means changeable. So a list is not a static thing. Once you create a list, the list can be added and removed, added to and removed from, I suppose you could say. So yeah. Okay, but first, to declare an empty list, you can do one of two things. So here are the two ways to declare an empty list. Here is like the list with the square brackets that are empty. And here's like the I think you would probably call it like a constructor, especially if you're in C++ or Java. This is definitely a constructor. In Python, this is definitely a list constructor, but well, you can kind of push and pop from lists. I'll show you how to do it in just a second. Yeah, you can use list functions, and I'll show you how to do that in just a second. So the empty list evaluates to false, by the way. So do you remember from last lecture, I should say, recall. So if I say if 0, or null string, or 0.0, or none, or what else? I don't know. or false. Print none of this will print, right? Because all of these things evaluate to false, right? If 0 or empty string or 0.0 or none or false, all of this is false, so it's never going to print. So that didn't print, right? Nope. So the same thing applies to so let's see what happens. Now, PyCharm is kind of telling us the answer because it's going to say that this code is unreachable because it kind of pre-evaluates this empty list bracket, and it's like, oh, hey, there's absolutely no way that this code is going to evaluate, but let's pretend we didn't know that, and we'll run it anyway. So we can see that empty list is false, right? So if empty list is true, oh, and here's something, I don't know, this is just like a pet peeve of mine. This is not really something that you have to worry about, but like, I always notice that people do things like if empty list is true, or if empty list equals true, or whatever. So actually, stuff like that, you don't need any of that, okay? So if you just want Python to evaluate like a variable, just let it alone, right? Just be like, if that variable name, right? And basically that what it's doing is it's asking if that variable converts to true as a Boolean, right? Okay. So empty list is false. So, okay. All of that is well and good, right? A equals 1, 2, 3, 4, 5. But now how do we access elements in a list, right? Like, what if you want to get, say, the third element? Now, here's a question. Which element is the third element here, right? So we have to talk about indexing, and that's what the slide is going to be about, but I'll just do it here. So the way that lists work in most programming languages, and in C++ they're called arrays, in Java they're called arrays or vectors. There's also vectors in C++. So yeah, so it's difficult to describe, right? Indexing starts at 0. So there's really two ways to describe it. You can really say this is the first element, right? The first element has index 0. The second element has index 1. The third element has index 2. And the fourth element has index 3. And then finally, the fifth element has index 4. And that goes on forever, right? Yeah, it goes up to length -1. So, okay, so that's how we get the index. Now, how do we actually access it? So, for instance, if I want to get the third element, I can print out A, and then I'm going to actually use this version of third element here. I'm going to print out A2, right? Because 0, 1, 2. That is the third element, even though it's index 2. So, yeah, computers... Well, so the reason why third element can be -3... Yeah, I'm not talking about the backwards indexing yet. We're just talking about positive indexing right now. So 3, cool. So that gets us the third element. Now, if you plug in, say, A3, right, that'll get us 4, right? And if we plug in A0, that'll get us 1. And so how do you index into a list? To index into a list, you add the square brackets and put the index in. A of -1 is 5 that's right, but I'm avoiding talking about negative indexing right now just for people who are new. So there are negative indexes, but the thing is that in a lot of programming languages, they don't have those for arrays and vectors and stuff like that. So we're only talking about positive indices right now. Yep, so we index it, and so, cool, there's 6 elements in this list. Okay. Let's see, I think all of this is stuff I've said already. Oh, right, so now, good. So if I try to print out, say, A17, right? Now, A17, right, you look at this list, there's 5 elements, so there's no 17 element. Not 100% sure what you mean by substring a list. So yeah, what you're going to get is an index error here, right? Definitely not talking about that right now. Remember, guys, so this class is intended for people who don't have a lot of programming experience. So I know that Python has a ton of advanced features, right? And even the TAs are kind of jumping at everybody's jumping at the gun to get it as far ahead as possible, as fast as possible. Basically, my entire job in this course is to like pull back on that instinct as hard as I can. So I want people to be able to understand the basic features of the language before we do anything like A135. That's called a slice. We'll get to that. I promise you we'll get to that. Today is loops and lists day 1, not day 3. So there's no 6th element, so it gives us an index error here, right? So if you ever get an index error, what it means is that we are going to not be able to find something in the list. So that's what it tells you. Okay, so how do you modify elements in a list, right? Right? How do you modify elements in a list? So what if we want to change elements in a list? So we can access the list at that index and assign a new value. So let me show you how this works. So let's say that we want to modify A4 and we want to make it the value 31, okay? And then we want to modify A2 and we want to make it 3. Well, I think A2 is already 3, so that's stupid. Let's make it 17. So I'm going to print out A here, and then I'm going to print out A here. That's a question that's so deep, Zan, that I cannot answer it. That's like, what's the meaning of life? Yeah, there you go. It's a good joke. So, okay. So let's look at this now. So what happened here, right? Remember that our first list was 1, 2, 3, 4, 5. And now in order to modify the list at position 4, what we're going to do is we specify A sub 4 is equal to 31, okay? And now once we print it, we see that the last element in the list, position 0, 1, 2, 3, 4, is 31 now, right? And everything else is unchanged. Cool? And then if we modify A2 is equal to 17, same business. 0, 1, 2, that's 17 now. And yeah. So there you go. Cool. And keep in mind that you can use variables in, so say you have my index is 3, you can do A at my index is equal to 14, and we can print out A again. I don't think I ever put that in my slides. I didn't really think about it because I was doing everything very explicitly. But if you have a variable, you can definitely stick it into an index. And yeah. So, okay, and then, so you see here that we've modified a sub 3, right, because my index is equal to 3. Now, of course, you're probably not going to just set an index to 3 and then modify it directly. Normally, there is some code in here that makes it seem more magical, right? So, okay, there we go. So you see that I changed access list 5 to this random number. And we have changed part 2 to changed. So, and again, I write this in my slides a billion times. And the reason why I write this in the slides a billion times is just because the indices go from 0 to the length of the list minus 1. And of course, once you're used to all of that, once you get used to it, you're going to think it's obvious. But you just always have to remember how the indexing works. I'm not going to tell you why. The reason why has to do with pointers and stuff like that in C++ and that kind of thing. But don't worry about it. So Python actually supports an operation called append. So basically in Java and C++, it's like the function pushback on a vector. What it does is append will add the new thing to the list. So let's do some appending. So a.append 4, well, let's append 3, a.append 17 again, a.append 65, 537, a.append, nope, a.append daffodil. Okay. So, there we go. So what we see here is that the list used to be just 5 elements, and now the list contains 3, 17, 65, 537, nope, and daffodil, right? So basically all of these things have now been added to the list, okay? So that's what append does. So you have to be careful because append is always going to stick it on the end. It's never going to stick it like in the middle. It's not going to sort it. It's not going to do anything like that. It's just going to stick it directly on the end of the list. And there it is. So, cool, right? Yeah, I mean, so it depends on what language you're talking about. The answer is generally yes, it's like an array list. It's also like a vector in C++. It's like a lot of different things, right? So the thing is that like it's like any dynamically allocated array-like structure, which I suppose is the most technical way to say it, you know? Okay. So, yep, so here's some examples of appending. So, why do we want or need lists? What if you want to stick something in a specific place? Well, if you want to stick something in a specific place, then is there a way to inject a value? Yes, there is. We don't generally teach it in this class, but there is a way to do it. So generally not taught. So don't use this. But I think there's an a.insert, and you see how it has index and object. So you can insert something in index 3. The object is now I am at index 3. So yeah, there's okay. So what's the point of a list, right? And so it's a decent philosophical question. Like, what is the purpose of life? What is the purpose of lists? What's the purpose of programming languages? So basically, the idea is that sometimes you need to make a list of things. You need, for instance, like, yeah, you need like a list of students. And so some people might ask, if you're new to programming, why don't you just declare a new variable for each one, right? Student 1 is equal to Aaron Aronson, student 2 is Aaron Berenson, right? Student, 10,391 is Zorblax. Of course, I added another Z just so that it was definitely the last element if you sorted all this by, alphabetical order. So basically the problem with this is what? What's the problem with this? Right, and so the problem is that generally, like, Python does not understand that student underscore 1 has anything to do with student underscore 2, or has anything to do with student underscore 10,391, right? All of these are just, it is repetitious, it is too long, I agree. This would be, yeah, it's a great waste of time, takes too long. If you need to access the students, there's no way to actually do that. You would have to have a list of all the variables, and then you're using lists again. So yes, that it is something like 10,391 variables. So all of your reasons are correct, right? This is not the way to do it. Clearly, this is bad, and the reason why it's bad is because there would be absolutely no way for Python to know which student you want to access, right? So instead, right? Like, if we want to make a list of our favorite movies or something, so now we got to talk about for loops. So if we're going to make a list of students is equal to the empty list, let's do list of movies, because movies are something I like. So what we have to do is we basically have to say, let's say that we're going to add, yeah, so you can, that's basically, lists are like groups of variables. Yep. So cycling a list. How can we read through a list element by element, right? Because this is the next question that you generally ask. If you don't know about it already, this is what you want. You're like, I really desperately want a way to go and scan through a list, right? I want to be able to access all the different elements and like check them, right? To see if one of them is the person I'm looking for, or the movie I want, or whatever. So we could try to access the list one by one, but you guys already are too far ahead of me. You know that this is terrible, right? You don't want to do this. So how do we stop? What if we add something to the list? How do we know, blah, blah, blah. So this is terrible. So we can loop through a list using a for loop. So now we get to talk about for loops. So, incidentally, how many of you have read the Most Dangerous Game short story thing? Just out of curiosity. I don't know why, but when I was in high school, we all had to read this thing. So, and it was a weird, silly little short story about, it was basically like Hunger Games in a short form. Okay. So, now that I have distracted you sufficiently, let's write a for loop. So how do we do that? Yeah, I'm just reading. So the primitive for loops we're going to use are called for each loops. So here's, and I'll try to make a distinction here between for each and for I loops. Python doesn't actually care, but I'll show you what we mean. So if we want a list and we want to loop through it, this is how to do it. So you say for value, and then in, right, there's this in keyword, the list. And then you can do something to the value, right? So let me show you an example of this. So give me some movie suggestions. Let's see, The Matrix. Hunger Games. Oh, I almost got myself murdered insulting Hunger Games in a movie theater. I got a bunch of teenage kids looking at me. I was like, it's not like we're here to see like Hunger Games or something. And man, I got some mean looks. Blade Runner. And Blade Runner 2019. Ooh, you know what? Fight Club. Not bad. Fight Blub. That's clearly how to spell it. Nightmare Before Christmas. Well, Star Trek is there's a lot of Star Trek. Maybe the motion picture, since no one watches that. You know what? Wrath of Khan. What else? Oh, wow. Ex Machina. Ex Machina. Cool. Okay. So, cool. I like Gladiator too. That's one of my good ones. Wow. Lots of... You guys are not disappointing me. I'm not going to add any more after this, but I am not disappointed. So, it's good to make your variable names meaningful. So, for instance... Oh, wait. What did I forget? In. I was like, wait, why is there an error there? So for movie and list of movies, we can print out the movie, right? And I know this is not very interesting in terms of, like, the for loop, but it's our first for loop, so cool. So you see here that the printing operation will print out each one of these things on a separate line, like this. Oh my goodness. Yeah, I mean, see, in class I'd have to make sure that all of you, shut up because I wouldn't be able to talk over this, but now it's fine. So that's like the first real advantage of online teaching, is that you can troll each other in the comments. So basically here, if you want to print something out in a loop, you can just go for value in the list, and then you can print the value. Here's something that I'll teach you right now, just if you're curious. What is this end thing? Well, movie, yeah, so movie is a variable, right? Movie is a variable, and it gets reset every time you go through the for loop to the next value in the list, right? So, yeah, so let me introduce the debug feature in PyCharm. It might be interesting to introduce it at this point. So let's do that. So the debug feature is kind of cool because what it does for you is it allows you to see what all your variables are at basically any given time. And using these buttons, it allows you to step either over or into or through different pieces of code. So let me just show you what I mean by this. So if I step to the next line, it tells me which movie is assigned to this variable here. And then if I step again, it'll go back to here. And then you see how the movie is still The Matrix because it's on this line. And so in this line, what it does is it gets the next thing. So you'll see that when I jump into the code again, it'll be Hunger Games and then Blade Runner 2049, Fight Club, Nightmare Before Christmas, Coraline, Star Trek, Ex Machina, the end. Okay, so that's how this generally works. And if you notice that I put this thing in here, this is called a breakpoint. So I'm going to take the breakpoint out so it doesn't stop there. But if you ever want to stop your code at a particular point, well, yeah, so I don't set the movie as a variable. Movie gets created here, and it gets reset every time it goes through the loop. That's what the for loop does, right? So for takes care of making the variable, and it will also change the variable to new values. Now, an interesting question was asked: does the variable still exist? Does movie still exist? And the answer is yes. But you have to be careful because the problem with using this variable is that it generally gets set to the last value that it was in the list. So it's not like it... So once it exits the loop, movie is always just whatever the last thing in the list was. So you got to just be a little bit cautious about that. You see how it printed Ex Machina twice? It printed out the last thing in there, and then it printed out the last movie again. So after it leaves the loop, it doesn't change. So now it is a variable elsewhere, right? So it does exist, right? So you can use it. It just doesn't change anymore. How does the loop know what movie is? Like, is it like the movies are only defined by their list? Since it's called a list of movies. Well, so what for does is it says, okay, when it sees this in keyword, it says, what kind of thing are you, right? And right now, all we know about are lists. And so what it's going to do is it's going to say, hello list, I know how to operate on you. I'm a for loop, you're a list, we know what this is. We know what's about to happen. So it's going to say, give me your first element. And so then the for loop assigns the first element, so the matrix gets assigned into movie, and then you can do whatever you want. And then the next time it goes through, it's going to be like, hey, you're a list, right? Just like last time, give me your next element, right? So it'll give you the next element, and then the next element, and then the next element, and then the next element. And it'll keep it giving you next elements until, of course, the list has no more elements to give, right? It's the giving tree that's run out of branches, and it's like, I'm done, I don't have anything more to say to you. And then it actually does something really crazy, which I'm not going to talk about. But it basically tells the for loop, it's like when the for loop tries to get next, this thing basically like says, hey for loop, here's a special horrible thing that if I pass it to you, it means it's the end. And so once it does that, once it reaches the end, then it automatically stops. Well, I mean, let's not talk about trees. So movie could be anything like tree. It wouldn't matter. Right, so, yeah. Oh, let's talk about something else. So if we say for C in hello string, print C. So you might think to yourself, wait a second, a string isn't a list, right? And you would be right. But PyCharm isn't yelling at us, right? It's not saying anything that's wrong here. So what's going to happen? Yeah, for each of the elements, it assigns something into this variable, right? Huh. Look at that. So Python knows that this is a string and this is a list, but basically what this is doing is it's saying, I'm a for loop, you're a string, I'm going to treat you like a list, okay? And the way it treats a string like a list is that it treats it exactly as if it were a list of characters. And so basically what it does, yeah, exactly, it pulls each character individually and prints it. Well, yeah, the space here is a character, right? So it will print the space. And you can see that the space is right here. And see, there's no space right there. That's just an empty line. There is a space right here. So, okay. Cool. And you can also access strings like lists. So you can also say print, say hello 2 or 3, I guess I did. So you see here it prints the L, 0, 1, 2, 3. So it prints this L. So it's actually a little complicated. Like, a string is technically not a list of characters. But really, yes. If you ever need to convert a string into actually a list of characters, for various reasons you might need to do this, what you can do is actually do this. You can say S is going to be, this is a string, not a list. You can actually say L is going to be equal to, like L of S is going to be equal to list of S. And so what this is going to do is it's actually going to convert it to a true, honest-to-goodness, actual list. So let me print S and print L of S, and you'll see what happens. So it says, this is a string, not a list, because that's what this says. Even though you can treat a string mostly like a list, there's one thing you can't do to a string. And I'll talk about that in just a second. So, but here you see this is truly a list, right? This is a list of individual characters within the string. No doubt about it, it's a list, right? So sometimes you might need this. Most of the time you probably won't. When using numbers, do you have to string them first to make a list? No. So if you just have a list, like list of numbers, right? And the list of numbers is like 3.14, 1.618, 2.718, I don't know, what's another good number? 0.577, those kinds of things. These are just all floats, right? For num in list of numbers, you can print out num type num. And so you see that all of these are still floats, right? They're not strings. Okay. I mean, you can kind of, if you want to, so if you do that, it's going to give you a list of digits, right? So what you're doing there is basically a list of digits equals list string, 2017, I don't know. So if we print list digits, then we get that. But this is not exactly, this is fine. There's nothing wrong with it. As long as you understand what it's about to do to your number, right? First, it's going to convert it to a string, and then it's going to break that string up into characters, right? So that's what list of string of a number is going to do. Okay. So let's use a for loop to select elements. So for instance, let me find that list. So basically, you can also put some code inside of for loops that make it more interesting than just print. So I downloaded, at one point I generated a random list of words, and there's that list. So here's the word list. Cool. And now let's copy paste the code. Hopefully it copy pastes correctly. This is the danger of copy pasting, right? I think this added maybe an additional space. Indentation is not a multiple of 4. I think it's probably... So here it's 3, and then here it's another 4. Yeah, so... Okay, so the good news is that if you hit Control-Alt-L, I think that should fix it. Yep. So basically what this is going to do is it's going to go through the word in word list, and it's going to print out each word that has an A in it. So I guess trap, squalid, stamp, plain, kind-hearted, treat, rap, preach, arm, damaging, yam, authority. I like how random this list of words is. It's very good. So, okay. So, and also, what do you notice here? Notice that the if statement is tabbed in 1, and the code in the if statement is tabbed in 2. Now, there's a gigantic and pointless debate about whether tabs are better than spaces, spaces are better than tabs, if it should be 2, 3, 4, or 5 spaces, if you believe in spaces, or if the tab should be whatever. Does indent have to be 4 spaces? No. So it has to be consistent. So, and that's the real problem. This is like one of the major problems with the Python programming language. If you and a friend are writing code together, and your friend says, I'm going to use 3 spaces, and I say, I'm going to use 4 spaces, then your code will not work together. You cannot just put it all in the same file and expect it to work. You're probably going to get a huge number of syntax errors. So that is a huge problem. It has to be consistent. So, you know what? All of you, I agree with you. Tabs are probably better than spaces. And the reason why I think that is because modern IDEs allow you to display a tab as however many spaces you want. But the Python community, in general, has decided on 4 spaces. So, what is a good definition of how in works? Good question. So, in is kind of like, it generates what's called an iterator. Basically, it takes your list and it basically wraps it in this object that says, I remember where I am in the list, and I can give you the next object in the list, if that's what makes sense. Why does tab not work for Emacs? That is definitely an office hour question. So cool. There you go. So so you can do this on your own time. The only thing that this was a comic that came out when I was in college, and then the guy who made it gave up on life and just kind of quit the comic. It was very sad. It was a great comic. Tab should work in Emacs. I think you might need to download a file. I think I have that file. I might do like a little announcement about it. So, okay. What does everyone think about the comic? Good, bad, indifferent? It doesn't work for you either? Oh. Yeah, I think there's a file, there's like a hidden file that you can put in your home directory. And if you do that, then it will fix all of the like tab space issues. All right. So, let's talk about range. So, range is range is a separate object in Python. And what it does is it basically generates all the numbers up from 0 to whatever this number is. So for instance, let's say that you want to do for I, which is an integer, in range 10, we'll print out I, right? So what do you notice that happens here? We print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's what range does. Basically, range prints out all the numbers starting at 0 and going up to whatever this is, but not including, right? Goes up to 10, does not include 10. So, cool. All right. Okay. So let's do the Gauss sum, which is something I talk about in just basically every class. I talk about it in 201, 203, 341, whatever. I talk about this thing all the time. The Gauss sum is the sum of all integers from 1 up to n. So this is like Gauss n. So for instance, if you do the sum from 1, 2, 3, 4, 5, this is equal to 15. If you do the sum 1 plus 2 plus 3 plus 4 plus ... all the way up to 50, this is equal to, what is it? I guess I can calculate it really fast. $12.75. Yep. So, yeah. So let's say we wanted to calculate a Gauss sum. So what we would do is we might say n is equal to input, enter n, and then we would say for I in range, and then here, remember, we're calculating up to n, so we do n plus 1, because this will go up to n plus 1, but not include n plus 1, so it stops at n. So then we're going to, let's call something the sum. Let's start it out at 0. So here's the thing. I generally, you have to avoid using the variable names min, sum, and max. And the reason why is that min is a keyword in Python, max is a keyword in Python, and sum is a keyword in Python. So avoid using any variable names that are keywords. So Emacs problems are really, as I say, Emacs problems are definitely like Discord office hour stuff. I'll help you guys out later with that. I don't want to spend class time on it. So I'm going to use this operator plus equals, and of course, I don't think I've actually talked about what plus equals does. So let me tell you what plus equals does. What it really does is it says the sum is equal to the sum plus I. So plus equals is kind of a reduced way to, it's a reduced way to talk about if you just need to add something onto a variable, you can just do plus equals. And incidentally, times equals, mod equals, exponential equals, all of these exist. Well, I mean, as it turns out, min, max, and sum do exactly what they they sound like. They're not too much of a mystery. It's just I haven't said anything about them. Okay. So let's see if I computed the number correctly. So enter 50, 1275. Cool. So that's right. Okay. So I think I want to talk about length of a list right now. So for instance, sometimes you want to actually access. So let me show you an example. So let's make a list is equal to 1, 2, 3, 4, 5. And what I'm going to do is I'm going to say for x in a list, we're going to print x, and then I'm going to do x. So this is going to square it, right? This is basically saying x equals x squared, right? And then I'm going to print x, and then at the end I'm going to print out a list. And I'm going to show you something weird, okay? Here's something weird. Get ready. So let's enter n, 5. So, okay, here it is. So when you add up from 1 to 5, you get 15. Okay, so here we go. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And then we print out the original list. Huh. Right? The original list is unchanged. Why? Okay. Why? Why? And the answer is, it depends on mutability of the element in the list. So if the element is mutable, if not, the element is copied. Well, no, but think about it here, right? I don't want to append these elements, right? X is its own thing, but why? So if a list, right, X is assigned to this element in this list, right? And here I tell it to square. And so 1 squared is 1, so that's fine. But 2 squared is 4, right? So once we square this, shouldn't this X be 4, which will change the element here in this list, right? Like, why isn't the list changed? Why isn't this 4 now? Why isn't this 9? Why isn't this 16? Why isn't this 25? Right? Because we pulled the element out of the list, we operated on the element, and now, and it did get changed, right? X is different now, but in the list it's not changed. And so the answer has to be something about mutability. And so this is kind of a tricky mess in Python. The good news is that all the basic types, int, float, string, bool, are all immutable, which means they cannot be changed. So technically what that means is that when you take an integer and you say x is equal to x plus 2, what Python is kind of doing here is it's creating a new integer, adding 2 to the old x, and then setting a new value. I don't want to talk about slices. How does it not change the value? It doesn't change the value because what this is doing is basically in a for loop like this, it's actually just making basically pretend like it's making a copy. So this x is being assigned to 1, this x is being assigned to 2, 3, or 4, or 5, right? So The same thing applies to strings, for instance. So if we have for s in, say we have a list of hello, robot, tensor, sphere. And so if I say s plus equals and more, and we print out s, and then we print out, well, okay, we actually have to put this in a variable, rando list. We have to enter n, 7. Okay. So here you see hello got assigned to s, we add and more, and it prints out. Robot gets assigned to s, and it gets printed and more. Tensor and more. Sphere and more. Right? But when we look back at the original list, right, when we print the original list again afterwards, it's unmodified. Right? So the reason why this is true, the reason why this is unmodified, is because strings are basic types, therefore immutable. Okay? So, do you know any example of something that is mutable, right? Is there a mutable thing in the universe? And the answer is yes, lists are. So for instance, let me show you an example where list of list So here's a list of lists. Oops, don't need the colon. And now what I'm going to do is I'm going to go for sublist in list of lists. We're going to print out the sublist. We're going to go sublist.append. Yeah, so s plus equals, this will do, does string concat. We're going to append 1729. And then we're going to print out the sublist again. And then finally, what we're going to do is we're going to print out the list of lists. So watch what happens, right? With great amusement. Let's enter n again, 8. Weird, right? So here, the sublist was the element 1. And then we added on 1729. 2, we added on 1729. 3, we added it on. 4, we appended. 5, we appended. Now look at what we have wrought. What have we done? Right? What have we done? Well, if you look at it, we've actually changed the elements inside of this list using append. And the reason is because sublist here is not a copy. It's actually what's called a reference. It's basically a variable that points to the same object. So this list object has some underlying, I guess the best way to explain it is maybe, let me just pull up a live board and then, I think the best way to explain it is, first let me refresh, pull this up. Pen, page, new. So basically every variable has some like internal memory location. Right? So basically, for instance, I don't know, what should we say? So it's some like location in RAM usually, right? So if we have a memory location, but then we also, each variable has a name. So the name is X, right? But X is actually just pointing to a specific place in memory, right? So if this is memory, here's memory, right? Here's RAM. This is where X is, right? And so basically, if X is a list, right? And say this might take up more than 1 byte or whatever. This is just some block of memory. If I say y equals x, then actually what that's doing is it's not making a copy, not copying. What it is doing, let me just erase this box here. So what it is doing is it's creating a new name called y, and is actually having that name point to the same internal memory space as x is pointing. Now, you might ask, why does it do it for lists and not for strings, ints, bools, and floats? Well, it only does this kind of what's called, you might call it a shallow copy. I don't like the term shallow copy because shallow copies are not copies. They are actually references. And this is what I mean by a reference. A reference is something where you have a variable name here, and now you have a new variable name that's pointing basically to this variable name, which is pointing to this. So basically it just gets assigned to point to the same memory location. So let me show you an example of how this actually works in Python, because this might be a little bit confusing. Let's make first list is equal to 1, 2, 3, 4, 3, 4, 5. And now I'm going to make second list equals first list. Okay? And now what I'm going to do is I'm going to say second list at, say, 2 is now going to be set to my favorite number, 17. And then I'm going to print the first list. Right? Now, you wouldn't be surprised if the first list... so, you know, what's going to happen here, right? The answer is complex because you have to be like, okay. So what's happened is we've created this list, right? 1, 2, 3, 4, 5 is sitting at some place in memory. First list knows where that is, right? First list is a variable who has a location. The location is the place where this list is. This, on the other hand, what this is doing is this is assigning this is assigning second list to basically point to this list. It's not assigning it to be a copy. So this is not a copy. Not a copy. Not a copy. So let's run this code, 58. So what you see here is, remember that this is printing out the first list. So if you just look at this last thing right here, what you notice is, right? This is weird. It actually modified the first list, right? I mean, if you print out second list, you're not going to be surprised that it's modified. Right? But the first and the second list are basically tied together now, right? As long as first list and second list are tied together like this, this is called a shallow copy. I'm going to call it a reference. I'm generally not going to say this. I know that some teachers like to talk about shallow copying versus deep copying. To me, there's either you copy something or you have a reference to something. A shallow copy, it really isn't describing what you're doing, and I know that some books use it. I just don't like the term. Anyway, but you'll learn as you go through and you become a coder. The one thing that is never in short supply is random and very strongly held opinions by programmers. Programmers will come to you and they will have extremely strong opinions about things, and they'll say, if you don't do it this way, you're just not even a developer. You should just go and quit your job. You should move to the moon, whatever. You know, I hate you. It's the worst, right? So you have to let that. So that is the moral of the story for the day, is that programmers have very strongly held opinions. And the last thing I'm going to do is answer the last question, which is, what if you don't want it to be a copy? Here's how to do it. Here's how to do it. If you wanted to, so this is a copy, so not modified. So now let's print out the third list. Okay. So what you see here is that the first list is, so second list is a reference to first list. So anything you do to first list, anything you do to second list, you do both, right? They're linked together. Third list, on the other hand, is a copy of first list because you put this list constructor on. So if you use the list constructor, it makes a copy, okay? And so because you use the list constructor to make a copy, you see that the third list, when you modify second list and first list are linked together, so it modifies both. But third list is not modified, right? Third list isn't modified. All right? So that's how to do it. And I promise you this is not the last time we're going to talk about references versus non-references. Like, you know, I promise this is not the last time. This is a concept that we're going to keep coming back to over and over throughout the course of the semester. The reason why we have to keep coming back to it is because it is really complex. So we will start the next class doing more about for loops. We're going to do more about lists, and we will discuss more about mutability. All right. Let's see. What did I not get to today? You know what? I basically finished the lecture. Yeah. I didn't talk about length, but that's okay. We'll talk about length and range more next time, and so that'll be good. All right. Cool, everyone. Good lecture, right? I think I've gone on long enough. I've droned on. I think everyone's bored, or hopefully. I mean, you know, the funny thing is I watch a drop off of attendance. People, I've had about 20 people drop out, but I think I've kept most of you entertained somewhat. Oh, don't worry. Don't worry, the outro is coming. Hang on. Stand by. Stand by. Wait, that's C++. I don't want that. Outro. Goodbye.